Hello, it is good to be with you guys again. So today, by the way, this is Pat Hoffheiser, your math helper here, and I wanted to provide you, well, actually, it was requested by the students to place a video up that sort of really puts the microscope down on this beginning piece of setting up your dosage calculations and also how to be successful showing your work. Okay, so this is an important video for you. And what we're going to do is just really focus on this how to set up the problem. What we noticed was the author, when they did for the textbook, when they did their demo video, they kind of glossed over this part a little bit, which for a student can cause confusion. So we're just going to highlight it here and go over some pointers to help you be successful with your dosage calculation work. The first thing I'm going to talk about is this T-bar. Okay, that's what this is called. So if you think it's like a lowercase t laying on its side here, and that's what it is, we've created a worksheet for you. It's in your Blackboard. You will see it, student answer worksheet, and that's what you need to submit all of your work on for your worksheets and for your quizzes. You can't submit it on the sheet that gives you the problems, okay? Because unless you're drawing your own T-bars, and we're trying to avoid that, we want you to write it out on the one that's provided so that we can read everything you submit very clearly, all right? So that's the importance of that. So you need to submit your work on the worksheet that's provided. Now, if you give me the answers to the problems, that's great, except think about that logically. I gave you the answers to the problems. The answers to the problems are already posted for you. So that's not telling me anything about what you learned from the module, right? What I want to know is, do you, the student, understand how you have to write out a dosage calculation problem? Wow, it's easy. Okay, it's easy right now because we're not too worried about the math part. We're worried about, can the student set this problem up correctly? Because as you go through the 4 levels of nursing school, each level, your dosage calculations level up like everything else does, and they become more complex with more data that you have to sift through, and you have to know like the back of your hand how to set these problems up. It'll set you up for really good success. Plus, it'll help you score points on tests that might push you just over the top so that you can pass, okay? And that's important in that moment. So this is the easy part. Master it now. It'll set you up for success. All right, so that's the T-bar. And when you see this in the top left box, there's going to be an equal sign, okay? Because what's on the left side of an equal sign has to equal what's on the right side of the equal sign. So this provides you with your logic piece right now. So we use the T-bar because it enhances the safety factor of when you're administering drugs. Instead of just scribbling something on a piece of paper, and you might get interrupted while you're doing that when you're at the med cart or whatever. This way, if you always use the T-bar, everything's laid out and it's systematic, and you can prove in a moment, if somebody were to question you about your calculation, you can say, yes, because I always do it this way. And that's what they're looking for, is to know that you're consistent in what you do. All right, so I already mentioned how to be successful with dosage calculations, worksheets, and quizzes. You have to submit the answer sheet that has the T-bars on it, and you have to enter your work into the T-bar correctly to tell us that you are doing it right, and that's how you show your work. So who am I? I'm Pat Hoffheiser. I'm one of your instructors. I've introduced myself a couple times on the videos. So let's talk about how to say my name. It's Hoffheiser. Okay, that's what it sounds like right there, but it's spelled differently. So when you look at the spelling, you just automatically go, oh my gosh, that's a tongue twister. Heiser. That's my name. All right. It's Pat, though. So my phone number is here, 269-985-7282. Feel free to reach out to me. If you text me, you got to tell me who you are because I work with all three levels of students, level 1 through level 3, and I won't have a clue who you are. There's my email address, hoffheiserp@westerntc.edu, and that is how you can reach out to me through email, and I will help you out. We can do group sessions. We can do one-on-ones, whatever your needs are to help you get through. Plus, if you have basic math challenges, we will set you up with Julie Callahan over in the Math Center. So here's Julia's name, Julia Callahan, Callighan, and this is her email address, CALLAGHANJ@westerntc.edu. She is our nursing math expert, and she understands dosage calculations extremely well and will help you, particularly if you're having trouble with basic math like fractions and decimals and things of that nature. She can definitely help in that area too. All right, so let's move on and let me show you exactly how we expect you to set up a problem. All right, so I have my T-bars here, and here's my first question. Now, the first thing you're going to notice as a new nursing student is, man, they leave a lot of information out in these things. And that's true, okay, because we are developing your critical thinking, okay? So you're going to start now learning to think like a nurse, which is different than thinking like an engineer, okay? Nurses think in a matrix, and I'm going to explain more about that when you get to simulation. So the questions will appear something like this on your first worksheet. 9 ounces equals how many milliliters? Now remember, we gave you the answers, okay? It's not about the answer. It's about how do I set up this problem? So the first thing when you're looking at this is to ask yourself, what is the question asking for? What is it asking me to do? It's asking you to convert ounces to milliliters. So your answer must be in milliliters. All right. Now that you know your answer must be in what unit of measure, that unit of measure goes in this box on the left side of the equal sign. So it's mLs. All right. And then the box right to the right of it also is going to get mLs, because what's on the left has to equal what's on the right. That's your logic that helps you to know I am correct. Milliliters equals milliliters. All right. So now that milliliter is the top part of your first fraction, which will be confusing at first because you're like, well, I need to know the milliliters. Yes, exactly. So you need a bridge, okay? So we're asking for ounces. So you're going to be looking for a conversion factor that is to do with milliliters and ounces. Now, ounces is on the bottom of this fraction, so ounces is going to have to be on the top of the following fraction, okay? So this here, this part, is a bridge. It's what's going to get you from here to here, all right? All of your bridges are known as conversion factors, and that's that card that I passed out to everybody. I believe I posted this on Blackboard, but if I did not, I will go back and double check and make sure that it's there. I did pass them out in the lacrosse class the other day, and I will be sure to pass some over to Julie Anderson so that she can give them to the group that is in Mauston or Toma. All right, so this goes through all of your, now you might see on the cards, dosage, it has grains on it. If you see that, you got to cross that out. We don't use grains anymore. It has your temperature conversions, your dosage conversions, your drop conversions. That comes in at level 2, but you have to memorize these before level 2. And then here are all your volume, weight, and length conversions. So you have to have all these memorized. By the time you get to level 2, you have to have them all memorized. But for right now, we'll let you use the cards in class, or we'll post it up on the board so that you can see it. All right, so what we're looking for today is how many ounces is in a milliliter, how many milliliters is in 1 ounce. So if you go up here, you'll see, look here, 1 fluid ounce is equal to 30 milliliters. Okay, so that's the conversion factor that I need in my problem. That's why you have to have them memorized. So it was 30 mLs is equal to 1 ounce. All right, that's my bridge, my conversion factor. Now the question is asking me, convert 9 ounces. The 9 will go here because ounces have to go diagonal. See, the beauty of this is that the problem, if you set it up correctly, the problem tells you what to do next. And that's what I need to know when I'm under pressure and feeling anxious trying to calculate a med. I need to know exactly how to do this. The problem is going to tell you how to do it. All right, so the 9 out. Now I'm going to cross out my, and let's see if I can do that with this platform that I'm using. This can be a challenge. Let's see, it's just going to be a pain. I'm not going to mess with it. I'm just going to tell you, you're going to cross off ounces and cross off ounces because they're diagonal, which is going to leave you with milliliters only. And that's where I take a moment and take a deep breath and say to myself, I set my problem up correctly. Because when you get to the more complex problems, you could have 9 fractions across this bar. And you need to know that every step you crossed out what crosses out, what matches crossed out, and then what remains is my answer. And I can go back to my question and verify. I have milliliters left. They asked me for milliliters. I am correct. All I have to do is my math. All right. To do your math, you multiply your numerators together, which is 30 times 9, which when you do that, and you will always have a calculator available, you're going to get 270. 270 what? Well, let's multiply our denominators together. There's an understood 1. Whenever you have nothing under a fraction, it is understood in math that there's an invisible 1 there, okay? So 1 times 1 is 1. 270 divided by 1 is equal to 270. I crossed off the ounces, so ounces won't be in my answer. Only milliliters. Only what's left goes in the answer. Milliliters. They asked for it in milliliters, and that would be my answer, 270 milliliters. Okay, so if I see this, the T-bar, and it's set up correctly, you were successful. That's what we want to see on your worksheets. Let's do several more examples. All right, this question says 3.2 liters equals how many milliliters? The answer, first thing I have to say is, what do they want in my answer? They want milliliters. Milliliters goes in my top left box, and because it's equal, milliliters is going to go in the box directly to the right of it. All right, so now I have to convert liters, so that's different. It's not ounces this time. It's all about your units of measure, okay? So liters has to go on the bottom. If liters is on the bottom here, liters is going to have to go on the top here. All right, again, this is going to be the bridge that gets me from here to there. I have to know how many milliliters is in 1 liter. And if you look at your cards, let's go look at our cards. See if I've got it up here yet. Let's find liters. All right, so 1 liter is equal to 1,000 milliliters. All right, so now you know what you're doing with that one. So 1,000 milliliters. I want this to look right. There we go. Is equal to 1 liter. All right, back to our problem. But we want to know 3.2 liters. 3.2 2 will go in here. Now I have liters on the bottom and liters on the top, so I can cross them out. What remains is milliliters. Okay, I know I did it right because I know I want milliliters, all right? Multiply across the top, and you're going to get 3,200 when you put that into your calculator. There's an invisible 1 under this one. 1 times 1 is 1. 3,200 divided by 1 is 3,200. 3,200 what? 3,200 milliliters, which is what the question asked me for. I have now demonstrated that I did my problem correctly. And let's keep going. This one I'm going to move down. Boom, boom. Okay. All right, these numbers, don't pay attention to them. They're all wacky. I didn't pay attention to them when I set this up. 11 ounces equals how many milliliters? Okay, so the question's asking you for milliliters. So milliliters is going to go in my top left box. Milliliters equals milliliters. All right. It wants to know 11 ounces. So my bridge here, my conversion factor, is going to be ounces. Now let me tell you, you're not always going to begin with a conversion factor. All right, you'll learn that as we move further along. Sometimes you'll start with what's available or other options. So it's not always going to begin with a conversion factor. But in this problem, it's telling you you must begin with the conversion factor. All right. And then because ounces on the bottom of this fraction, you're going to have to place ounces on the top of this fraction. So your conversion factor is going to go here. Again, we remember there's 30 mLs in 1 ounce. And in my problem, I need to convert 11 ounces. Cross off the ounces because they cross match. I'm left with milliliters. That's what I want. All right, let's do our math on this one. All right, 30 times 11 is 330. 1 times 1 is 1. Divided into 330 is 330. 330 what? We had decided that we were down to milliliters, which is what was requested. We have now answered the problem correctly, and you set it up correctly, and you showed your work correctly. All right, let's move down to one that was a little bit different. Okay, so this is an I&O question, intake and output question. But the person who was calculating the I&O added everything up in ounces. They said the patient had 4 ounces of apple juice and 8 ounces of broth and 6 ounces of water. And we want to know what is the total milliliters. All right, so get rid of that. All right. What is the total milliliters? All right, so I have to convert this. But first, I have to add. So I have to add 4 plus 8 plus 6. 4 plus 8 plus 6 gives me 18 ounces total. So it's the total that I need to convert into milliliters. So it gives you a real-world area where you can see, oh, I see where this is going to start to apply to my actual practice, okay? All right, they asked us to put it in milliliters. So again, milliliters equals milliliters. Milliliters is on the left, milliliters is on the right. This one again is going to begin with a conversion factor. It doesn't always happen that way. All right, ounces on the bottom, so ounces is going to have to be on the top of this one. All right, conversion factor. How many milliliters are in an ounce? 30 milliliters is in 1 ounce. So as you do these, you're actually memorizing your conversion factors. I have 18 ounces I need to convert. Yep, 18 ounces. All right, invisible 1 under here. All right, so let's do the math. You can grab your calculator and do the math on that one. And it should give you 540 milliliters because we divide by that 1. You add up all, you multiply all your numerators, and you divide them by all the multiplied denominators. So really you're always just doing multiplication and division, okay? And then later on understanding the principles of decimals, but we'll get into that more later. All right, the next one is kilograms to grams. So they want to put 2.5 kilograms into grams. All right. So where they're asking for grams. So grams equals grams. All right. So now it's kilograms. So kilograms will have to go on the bottom. All right. I have to go back to a conversion factor. So you're going to look for how many grams are in 1 kilogram. All right, so it's 1,000 grams is in 1 kilogram. Kilograms is on the bottom here, so kilograms must go on the top here because you have to cross cancel your units of measure. It was asking for 2.5 kilograms. 2.5 kilograms. So there's a couple of pointers that I'm going to tell you just for good practice, okay? I always cross out what I've used in a problem. So they'll have a lot of different numbers on here. And as we teach you to decipher the questions, so once I use that 2.5, I kind of just cross it out in the problem so I know I used it. Now I'm going to cross off what matches. Kilograms and kilograms match, so cross them off. I'm left with grams. Grams is what they asked me for. So now all I have to do is do the math. So it's 1,000 times 2.5 is going to give me 2,500 divided by 1, because 1 times 1 is 1, and it's grams. So 2.5 kilograms is equal to grams. Now, another thing to think about when you're doing your math is to ask yourself, is it reasonable? Is my answer reasonable? I set it up correctly, and if my fingers hit the right keys on the calculator, I got the right answer. And then you say to yourself, wow, that's a lot. 2,500, that's a lot, big number. But it makes sense because I wanted grams, and 1,000 grams is a big number, okay, compared to kilograms. 1,000 in 1, it makes logical sense, okay? You can almost do that just visually, but it's a good time to learn to question, does it make sense before you actually give a medication? What would you do if you're not sure? What would you do if you think, it doesn't make sense to me? It doesn't look right. There's a little red flag going off in the back of your mind. That's when you phone a friend, okay? You need help. You need somebody to verify this. Now, you're a student nurse, so who's going to verify for you? Somebody with more experience than you have, so it's not going to be your best student nurse friend because they don't have any more experience than you do, right? So you need an instructor, a preceptor, a registered nurse with more experience, okay? So those are the people that you're going to go to. And sometimes they'll say, yeah, you did it wrong. That's okay. You're being safe. You didn't give it to the patient, so it's a good catch, right? And they'll help you figure out. And sometimes they'll say, no, actually you did it right. This is why it seems like it's the wrong number to you, but this is the rationale. And they'll help you to understand it. So there you go. That is the key. This is the key. Setting up this very beginning of your problem makes it so that you can continue on because you can only cross-cancel units of measures. That's the beauty of dimensional analysis, and it will set you up for absolute success. But like always, it still may be confusing for you, and that's okay. If you're still confused, reach out to me. Let me know. We'll get you supported. We'll get you resources, and we will build on your strengths and get you where you need to be with your dosage calculations now while it's easy. You just have to speak up and let us know. Have a great day, everybody. I hope you're doing well.